class with me. Today we talk about related rates of change. This is an application of basically chain rule. All right, here this is the question, and you can imagine this particular circle is expanding, is the hot spot, is expanding, and the rate of increase here is given. The radius is increasing at the rate of 3 centimeters per second. That is, it's getting larger and larger, the circle. So with this, is that always write down the information. The rate of the circle is increasing. Rate here is referring to with respect to time. Usually time is represented using t. So in this case, we know dr dt is equal to 3 centimeters per second. The unit of measurement of time is second. And we want to find an expression for the rate at which the area of the circle is increasing. Basically, what I'm looking for is dA dt. And I want this to be in terms of r, which is the radius. So what is dA dt, right? dA dt using chain rule is dA times dr times dr dt. So you can see that the r and dr cancel off. So in order to find an answer, first I need to find out the relationship between a and r. Luckily, this is not very difficult because this is a circle, and I know that the area of a circle is pi r squared. Therefore, dA dr with respect to r, that is the derivative of area with respect to r, is 2 pi r, and dA dr now is 2 pi r times dr dt. In this case is given as 3, so the answer is 6 pi r. In this case is centimeters square per second. That's it. Now this question usually doesn't stop here. Usually the people will ask, for example, how much is the area, what is the rate of the expansion of the area when the radius is 5 cm, for example? So in this case, you would have to do something extra. If you want to find out the rate of increase of the area when the radius is at 5 cm, then I simply put 5 into the r. So in this particular case, I would have 30 pi centimeter. That is, at radius, when the radius is 5 cm, the area is increasing at this particular rate, 30 pi centimeters square per second. Now let's go to the next question. Here I have the oil is dripping down, and when the oil hits the table, for example, it forms a film, and this film, we're going to assume it to be circular, and it has a uniform depth. So we can, that is basically, this is a cylinder, all right? And what I want to write down this information, that is, the oil is dripping on the surface area at the rate. This is centimeter cube per second. That means I have dV dt. That is 0.2 pi. Next, this is a cylinder. Cylinder means volume of the cylinder is pi r squared times h. And h has a uniform height, that is 0.1. Therefore, this is 0.1 pi r squared. All right, that's my v. Next, find the rate at which the radius of the circular form is increasing. When the radius is 5 cm, that means I want to find dA, dr dt when r is equal to 5 cm. So this is what I need. So in order to find the answer to that, that is dr dt here is basically dr over dA times, well, So basically the answer is the R over dV, because we have V here, times dV dt. Okay, so we need to first find the R dV. And in order to do that, I need to use this formula in blue. So you can see here, dV dr is equal to 0.2 pi r. That is 2 comes down. 2 times 0.1 is 0.2. So pi r. And the R dV is 1 over dV dr. So that will be 1 over 0.2 pi r. That is. Now I can write this as 1 over 0.2 pi r times dV dt here is 0.2 pi. So this is perfect. That actually cancel out, and I'm left with 1 over r. That is the radius, the rate of increase of the radius is inversely proportional to the r in this case. And if I want to find the r dt now at r equal to 5 cm, then this is just basically 1/5 centimeter per second. All right, so let's go to the third question. You might want to try this question first before you check the answer. All right, pause the video first. Okay, welcome back. So how do we sort this problem out? First, we have the velocity. Velocity is given, all right? And remember, velocity is basically ds dt. That is the derivative of displacement over time. And what I need now is to find an expression for the acceleration of the body in terms of s. Usually we do it in terms of t, but this time we want it in terms of s. So what is a? Well, a is the derivative of velocity with respect to time. But I don't really have time, so I cannot do that. So the next thing is dv ds times ds over dt. All right, dv ds is so given here is v is equal to s squared minus 5. So dv ds in this case is 2s. Therefore, I have 2s times ds dt, but ds dt is v. So that is s squared minus 5, because ds dt is v and v is s squared minus 5. Therefore, simplifying this, I will have 2s cubed minus 10s. So here's the answer.